Hi, in this video, I am going to show you how we can perform the Pearson correlation coefficient as well as simple linear regression analysis on our data. So the assumption here is that as you grow older, the amount of salary that you earn is going to increase. So that is actually the one that we are going to prove. So we have on the left side the age of the participants, and on the right side the amount of salary that each participant is earning, right? So in order for us to perform Pearson correlation coefficient, we must first what we call fulfill the fact that the data must be normally distributed. Okay, so I'm not going to show you how to do normality check again. You can refer to my previous video. Okay, so what I'm going to do now is to draw the correlation coefficient for the data set. Okay, and then later on trying to regress as well as coming up with the mathematical equation to represent the association for prediction ability. So to do the correlation coefficient is very simple. Pearson correlation coefficient, you click analyze. Okay, then you go to correlate, then you go to bivariate. Bivariate means two variables. So we have two variables, the independent and the dependent variables. The independent variables being the age, while the dependent variable is the salary or amount of salary earned. So we click bivariate. Okay, then we transfer the salary earned as well as the age of respondent into variables. Make sure that you click Pearson, not Spearman, because these data are normally distributed. Okay, here the IBM SPSS allows you to choose either you want to have two-tailed hypothesis testing or one-tailed hypothesis testing. So I would retain the two-tailed hypothesis testing. Right? You can click option, you can see the mean and standard deviations. Continue and then OK. So now you are prompted with these two tables. The first table is about the descriptive statistic. You can get the mean plus minus standard deviation and all. So in the mean age of the respondent is 33.07 plus minus 9.145 years old. While the mean of salary earned is 3,546 ringgit 67 cent plus minus 1,331. So the standard deviation is quite big actually for salary earned. Okay, now you look at the correlation coefficient table. As I mentioned in my lecture, for correlation coefficient, we look at two things. Number one, we look at whether the association is statistically significant. And then if it is significant, how strong is the strength of the association? Now you go to significant two-tail, you can see that it's 0.000, meaning that it's highly significant. So the association between age of respondent and salary earned is highly significant, statistically highly significant. And the strength of association, the R value is 0.900. So 0.900, according to the guideline that we used, can be considered as strong relationship, nearing 1. So it's almost very strong association. Yes, you can see the association now, but you can't predict because you don't have any mathematical equation. So for that purpose, we are going to pursue our analysis with linear regression analysis. So you click again analyze, you go to regression, you go to linear regression. If you look at the selections of regression here, there are many different types. You can see binary logistic, multinomial logistic, ordinal, whatever, non-linear. So these are the different types of regression analysis, but we are not covering this. We are going to cover only the simple regression. So now you click linear regression. Okay, so the dependent will be the salary earned. Age will be the independent. Okay, then you can check statistic if you like. You can look at the estimate, whatever, continue, don't change that. Plots, okay, don't change that. You go to option, Okay, maintain at 0.05. Okay, right. Okay, that's about it. Okay, then we can click OK. So now you are prompted with these few tables of regression analysis. Okay, so it is shown that the method that we use is enter. Okay, so the correlation was 0.900. So that translates into R square of 0.810, meaning 0.9 multiplied by 0.9. So you will get 0.81. So that is the regression value. Now, you can look at the association again. It's significant 0.000. Okay, and then you have the coefficient. So remember that I said the equation for linear regression is y equals to a plus bx. So in this context, the equation will be y equals to negative 786.791. That is actually a, plus b is 131.052. X. So y equals to a plus bx will be y equals to negative 786.791 plus 131.052 x. So that is the equation that we can derive from this table. But you can't see the diagram, right? You would like to see the what we call the straight line going across the data set. So that is easy. You go to graph, chart builder, right? So you select scatter plot, scatter and dot. Select the simple scatter dot. Bring that to the empty location above that. Okay. So then you transfer. So the independent variable will be the age. Age will be in the x-axis. The salary earned will be in the y-axis. Okay. Then you click OK. So now you have these scatter plots, but still you don't see the line. So you double click it. Okay, you click this button, right? Add fit line at total. So this is the fit line. So close, then you have it. This is the equation, the R square value. You already have the equation, and now you have the straight line going across your data set. So that's how you do the Pearson correlation coefficient. That later you proceed with simple regression.